Hey guys, this is Space Train, your daily express till the edge of the space. And today we will talk about what happens when you go faster than light. Grab your tickets and let's go. Don't forget to subscribe to get unlimited pass on our expedition. What if you traveled faster than the speed of light? If you could travel at the speed of light, you'd be able to go around the Earth 7.5 times in a single second. When we were kids, we were amazed that Superman could travel faster than a speeding bullet. We could even picture him chasing down a projectile fired from a weapon, his right arm outstretched, his cape rippling behind him. If he traveled at half the bullet's speed, the rate at which the bullet moved away from him would halve. If he did indeed travel faster than the bullet, he would overtake it and lead the way. In other words, Superman's aerial antics obeyed Newton's views of space and time, that the positions and motions of objects in space should all be measurable relative to an absolute, non-moving frame of reference. In the early 1900s, scientists held firm to the Newtonian view of the world. Then a German-born mathematician and physicist by the name of Albert Einstein came along and changed everything. In 1905, Einstein published his theory of special relativity. We talked about it in our other video, you can check link down below. The starting idea for this theory is, there is no preferred frame of reference. Everything, even time, is relative. Two important principles underpinned his theory. The first stated that the same laws of physics apply equally in all constantly moving frames of reference. The second said that the speed of light, about 186,000 miles per second, 300,000 kilometers per second, is constant and independent of the observer's motion or the source of light. According to Einstein, if Superman were to chase a light beam at half the speed of light, the beam would continue to move away from him at exactly the same speed. These concepts seem deceptively simple, but they have some mind-bending implications. One of the biggest is represented by Einstein's famous equation, E equals mc squared, where E is energy, m is mass and c is the speed of light. According to this equation, mass and energy are the same physical entity and can be changed into each other. Because of this equivalence, the energy an object has due to its motion will increase its mass. In other words, the faster an object moves, the greater its mass. This only becomes noticeable when an object moves really quickly. If it moves at 10% the speed of light, for example, its mass will only be 0.5% more than normal. But if it moves at 90% the speed of light, its mass will double. As an object approaches the speed of light, its mass rises precipitously. If an object tries to travel 186,000 miles per second, its mass becomes infinite, and so does the energy required to move it. For this reason, no normal object can travel as fast or faster than the speed of light. That answers our question, so our video ends. Wish you a great day. Just kidding. It did not stop science from imagining tons of different ideas. What happens when you go more than the speed of light? They call it superluminal speed. Our most loved idea is that, when you go fast your time slows down. Let's have a little fun and modify the question slightly. What happens if you go almost as fast as the speed of light? We covered the original question, but what if we tweaked it to say, what if you traveled almost as fast as the speed of light? In that case, you would experience some interesting effects. One famous result is something physicists call time dilation, which describes how time runs more slowly for objects moving very rapidly. If you flew on a rocket traveling 90% of light speed, the passage of time for you would be halved. Your watch would advance only 10 minutes, while more than 20 minutes would pass for an earthbound observer. So does it mean that if you go faster than light, you go backward in time? Alright, we get it. You can't go faster than that, but then, why we have word superluminal speed, if it does not even exist? Alright, let's move on. You would also experience some strange visual consequences. One such consequence is called aberration, and it refers to how your whole field of view would shrink down to a tiny, tunnel-shaped window out in front of your spacecraft. This happens because photons, those exceedingly tiny packets of light, even photons behind you, appear to come in from the forward direction. In addition, you would notice an extreme Doppler effect, which would cause light waves from stars in front of you to crowd together, making the objects appear blue. Light waves from stars behind you would spread apart and appear red. The faster you go, the more extreme this phenomenon becomes until all visible light from stars in front of the spacecraft and stars to the rear become completely shifted out of the known visible spectrum, the colors humans can see. When these stars move out of your perceptible wavelength, they simply appear to fade to black or vanish against the background. But the crazy fact is that, if you held a mirror in front of you, you'd look exactly as you always have. In fact, one of the surprising things about special relativity is that if you weren't looking at all of the scenery passing you, you couldn't tell that you are moving at all. But from the perspective of people standing on the sidelines, things look really cool. Stationary observers would notice that your entire ship, or race car, or whatever you're driving at 99% the speed of light, is compressed along your direction of motion. If you're standing the right way, it'll look like you've lost weight and that your body has been flattened under a giant stone. So if you decide to go at the speed of light, make sure no one watches. Of course, if you want to travel faster than a speeding photon, you'll need more than the same rocket technology we've been using for decades. Perhaps pulling on blue tights and a red cape isn't such a good idea after all. There are lots of questions left, so don't space out, and live some space. I hope you enjoyed this video. If you want to see more, subscribe and click the bell button, to get notifications on our latest videos. If you are still here, grab your knowledge and get out of my train.